Have you ever imagined that, in just a single moment, you could be pulled into a region of space so dark that no light can escape, where time nearly comes to a halt, and every law of physics you've ever known breaks down completely? It may sound like a scene from a science fiction novel, but this is the cold, unsettling reality of what we call a black hole. These cosmic monsters don't just exist. They serve as strange checkpoints where the line between science and the mysterious begins to blur. What would happen if you, a living, breathing human, crossed that irreversible boundary, the event horizon? Would you vanish instantly, be stretched into a thin stream of particles by immense gravitational forces? Or could you step into another dimension? Are black holes cosmic prisons? Or could they be gateways to parallel universes, to realities beyond anything we've ever imagined? The question isn't just, what happens if you fall into a black hole? But rather, would you still be you after crossing over? Let's explore the furthest edge of human understanding. What is a black hole? A deeper look into the cosmic monsters. The physical nature of a black hole, a place where the laws of physics collapse. A black hole is not just a dark region that sucks everything in. It is a space-time structure formed when an enormous mass of matter is compressed into an extremely small volume. The result is a gravitational field so strong that nothing, not even light, can escape it. In other words, a black hole is not a solid object, but a region in space with a boundary called the event horizon. Once you cross this boundary, there's no turning back, you're trapped. Einstein's theory of general relativity describes space as a fabric that can be curved by matter. A black hole is the deepest dip in this fabric, creating an infinite pit in space-time. Anything that falls in will follow an unpredictable path where classical laws of physics no longer apply. Particularly, the center of a black hole, known as the singularity, is where matter density and the curvature of space-time become infinite. This is where current physics breaks down. No one truly knows what happens there. Space could become time, time could become space. Concepts like cause and effect could be reversed. Types of black holes, not just one kind of monster. The world of black holes is more diverse than we might think. Here are some interesting categories. Primordial black holes, formed right after the Big Bang. They could be as small as an atom but have a mass comparable to a mountain. They may be remnants from the early universe and are strong candidates for dark matter. Stellar black holes, these are the result of the death of massive stars. When the nuclear fuel runs out, the pressure can no longer resist gravity, causing the star to collapse in on itself, forming a black hole with a mass from a few to tens of times that of the Sun. Supermassive black holes, found at the centers of nearly all galaxies, including our Milky Way. These can have a mass ranging from millions to billions of times that of the Sun. The mystery is, how could they form so quickly in the early universe? The answer remains unknown. Intermediate mass black holes, the lost species of black holes, these are the missing link between stellar black holes and supermassive ones. They are difficult to detect because they are not at the centers of galaxies and have minimal interaction with their surroundings. However, astronomers have recently begun detecting gravitational wave signals possibly caused by collisions of intermediate mass black holes. Charged and rotating black holes. Theoretically, black holes don't just have mass, they can also have an electric charge and angular momentum. These types are more complex in structure, such as Kerr black holes rotating and Reissner-Nordstrom black holes charged, where space can be twisted, allowing for strange pathways inside. A black hole, at its core, is not a hole in space, it's an extreme state of space-time. Once you understand this, you'll realize that black holes not only attract matter, but also pull humanity's imagination into a maze of unsolved questions. What happens when you fall into a black hole? The observer's perspective. The outside observer versus the one falling in two parallel realities. Imagine you're standing a few thousand kilometers away from a black hole, watching a fellow astronaut approach it. You see them slow down as they near the event horizon, seemingly frozen at the edge of the black hole. The light from them dims, shifts to a deep red, and then vanishes. This is gravitational redshift, a strange effect where gravity bends both time and light. From the perspective of the outside observer, the person falling in will never actually cross the event horizon. They just stop, fade, and disappear into darkness. But this is just an optical illusion. For the person falling in, everything is entirely different. Nothing strange happens at the event horizon according to Einstein's theory of relativity. There's no explosion, no cracking of the universe, you simply pass through as if crossing an invisible boundary. Time flows normally for you, but the destination is uncertain. Tidal effects, stretching, and the final transformation. As you approach the center of the black hole, especially in a stellar black hole, a terrifying phenomenon occurs: spaghettification, or the noodle effect. This happens because of the immense difference in gravitational forces between the part of your body closer to the black hole, your feet, and the part farther away, your head. You will be stretched vertically and compressed horizontally to the point where even the atoms in your body can no longer stay together. In smaller black holes, like stellar black holes, this happens before you even cross the event horizon. But if you're lucky enough to fall into a supermassive black hole like Sagittarius A** at the center of the Milky Way, you could pass through the event horizon more gently. Only when you approach the singularity does the tidal force truly become horrifying. Consciousness inside the black hole, does awareness still exist? An unanswered question: if you don't get destroyed immediately, would you still be aware of being alive? What would you feel for a few seconds or minutes, or just an instant that lasts forever? Some theoretical physicists believe that from the perspective of the person falling in, they would continue to exist, at least until reaching the singularity. But what happens to consciousness when you're compressed to infinite density? This isn't just a physics question, it's a question about the very nature of being. Could there be an experience inside a black hole that can only be known by sacrificing life itself? Or is it a place where memory, matter, and even the self completely vanish? No one has ever returned to tell, and perhaps that's what makes black holes so fascinating in the universe. Inside the event horizon, the forbidden zone of cosmology. Imagine you're drifting through a threshold of no return, a metaphysical boundary where not only your body but also time, space, and your consciousness are warped beyond recognition. This is the event horizon, the final boundary where, once crossed, no signal, no light, and perhaps no physical concept can still apply. Space-time collapsing, when the structure of the universe destroys itself. Inside the event horizon, you're no longer part of the ordinary universe. Instead, you're being led into a place where the laws of physics, as we know them, cease to exist. At the center of the black hole is the singularity, where matter density and space-time curvature reach infinity. The concept of three-dimensional space and linear time completely collapse. Einstein's general relativity predicts the inevitable collapse of space-time at this point, but it can't explain what happens inside it. This is where classical physics fails, and quantum mechanics, which describes the microscopic world, can't intervene without a unified quantum theory of gravity. Some physicists describe the singularity as a mathematical black hole in equations, a point where physical quantities exceed the limits of our understanding. Objects that get close won't just be physically destroyed, but also, informationally, all data about their initial quantum state seems to be erased, a severe contradiction to the information conservation principle in quantum mechanics. Reverse time and the possibility of other universes? One of the most intriguing aspects inside the event horizon is the potential reversal of time and space. In normal space, you can choose to go forward, left, right, but time only goes one way. However, inside the black hole, forward now becomes time, and you can't fight it. You're sucked toward the singularity like drifting on an unyielding river. Some hypotheses based on solutions to Einstein's equations, such as the Kerr black hole, a rotating black hole, suggest the existence of a wormhole, a tunnel through space-time that could lead to another region of the universe, or even a completely different universe. In this model, the singularity doesn't destroy you, it transforms you. This concept paves the way for the idea of white holes, the opposite of black holes where matter and light can only escape, not enter. Some physicists believe that black holes in our universe might be white holes in another universe, and vice versa. This raises the question, could death in a black hole be a rebirth in another universe? Beyond the limit, what science can't yet reach. The event horizon is not just a physical boundary, it is a symbol of the limits of human knowledge. What happens inside it is a forbidden zone, unobservable, unrepeatable, unmeasurable. Scientists refer to this as horizons of ignorance. And because it's unreachable, the inside of the event horizon has become fertile ground for hypotheses, from doors to parallel universes to the origin of the next Big Bang, to a place where the data of an entire universe could be encoded. Some theories even suggest that objects falling into a black hole don't actually disappear but are replicated on the event horizon's surface as a 3D image, known as the holographic principle. In conclusion, inside the event horizon is where reality, as we know it, stops. It's not just a physical destination, but a doorway to a completely new frame of reference where every definition of existence, time, and the nature of matter must be rewritten from scratch. The information paradox: when the universe's data is erased, In modern physics, information is not just data, it is a fundamental component of everything, from subatomic particles to stars, from hydrogen atoms to living beings. And because of this, the question, what happens to information when it falls into a black hole, is not just a technical issue, it is one of the greatest paradoxes that threatens the consistency of all theoretical physics. Hawking radiation, black holes aren't completely black. In 1974, Stephen Hawking shook the scientific world with a bold discovery: black holes are not completely black. Contrary to the previous belief that black holes only absorb and never emit radiation, Hawking suggested that quantum effects near the event horizon cause black holes to emit radiation, now called Hawking radiation. This emission causes the black hole to gradually lose mass and energy, in other words, it slowly evaporates. If this process goes on long enough, especially for small black holes, the black hole will eventually disappear from the universe. But what happens to the information about the objects that once fell into it? Is that information permanently destroyed, or is it somehow encoded in the radiation emitted? This is the crux of the black hole information paradox, a deep conflict between relativity, which allows information to disappear, and quantum mechanics, which asserts that information is always conserved. Black hole firewalls, the violent death of the equivalence principle? To resolve this paradox, a controversial hypothesis has been proposed: the black hole firewall. According to this theory, a region of extreme energy exists at the event horizon, enough to burn everything that touches it. This would allow information to escape the black hole rather than being swallowed. However, this theory violates Einstein's equivalence principle, the principle that states nothing special happens at the event horizon for a falling person. In other words, if there's a firewall, then Einstein was wrong. And if there's no firewall, the information may truly be lost, something quantum mechanics doesn't allow. The holographic principle and possible solutions from a higher dimension? One of the most fascinating solutions is the holographic principle, which suggests that all the information about matter falling into a black hole isn't lost, but instead encoded on the event horizon's surface as a 3D image. Imagine how a 3D hologram contains all the information about a three-dimensional object. This principle suggests that information doesn't disappear. It's just translated into another language. This theory also opens the door to the idea that the universe we live in might be a projection of a higher reality, where information is stored and operates in ways we cannot yet imagine. In conclusion, the question of information inside a black hole is not just a physics problem. It's a philosophical challenge about the nature of reality, time, and existence. Could everything we've ever been, known, or experienced completely vanish without a trace? Or does the universe have some mechanism to remember everything, even in its deepest darkness? Black holes in culture and fiction, wormholes, time travel, and the future of humanity. Wormholes and space travel. Some theories connect black holes with wormholes, tunnels that link 2 points in space or time. If stabilized with exotic matter, they could potentially become a means for space travel. Can consciousness survive? Some philosophers and theoretical physicists imagine that consciousness is not purely a physical phenomenon and might be separable from the body. So, if a person were to fall into a black hole, could the non-physical part of them, the soul, escape or survive beyond the event horizon? Are black holes quantum computers? One strange yet fascinating hypothesis suggests that black holes might function as powerful quantum computers, storing information as entropy on their event horizons. This idea is reminiscent of the holographic principle, which posits that all information in three-dimensional space is encoded on a two-dimensional surface. Conclusion: falling into a black hole, death or rebirth? Falling into a black hole is certainly a death sentence for the physical body, but it is also an opening for scientific thought. It not only forces us to reconsider the nature of time, space, and matter, but also challenges every boundary of human understanding. Within a black hole, where all laws of physics are bent, lies the potential for the next great theories, such as quantum gravity or answers to the nature of consciousness and the essence of existence. We may never return if we fall into a black hole, but contemplating it may bring humanity closer to the ultimate truth of the universe.